Hello everyone. Now in this video I will explain how to find integral of absolute value functions. Before we start, let's remember how to write absolute values as piecewise functions. Remember, if whatever we have inside absolute value is positive, then we take this expression or stuff out of absolute value as it is. But if stuff inside absolute value is negative, then we take the opposite expression out of absolute value. So in this integration, we are going to use this idea. In order to find integral of absolute value x minus b dx from a to c, first thing to do is, as we did in writing absolute values as piecewise, find the critical value. Find the value that makes absolute value 0. What makes absolute value 0? X being equal to b makes absolute value 0. So we are gonna break the integral up into two pieces. Integral from a to this is critical value plus integral from this critical value to the upper bound. Okay, lower bound to the critical value plus critical value to the upper bound. What about the functions inside? Remember, as we did here, we are going to use the idea of writing absolute value as piecewise. When we have a number less than b, then inside absolute value becomes negative. If inside is negative, then we will take the negative expression out of absolute value. So instead of writing absolute value x minus b in the first part, we will be writing negative x minus b. This is how this expression comes out of absolute value, because we have a number less than b which makes inside negative. Plus, in the second part, when I pick a number more than b, then it will make inside positive. When inside of absolute value is positive, it will come out as it is, like x minus b. So this is how we solve absolute value questions. Now let's take a look at the first question, exercise 9. Integral from negative 1 to 1 of 1 minus absolute value x dx. Now, what makes absolute value 0? 0. So I'm going to break this integration into two parts. Integral from lower bound to the critical value of 1 minus how this absolute value x comes out. Since we have a number less than 0, then it will come out as it's negative, as its opposite. So it will come out as negative x dx plus integral from this boundary number, critical value, whatever you call it, 0 to the upper bound. When you pick a number more than 0, it will make inside positive. So absolute value x will come out as it is, dx. So this is how I will break this integral into two parts and evaluate. In the first part, I have negative x, which is 1 plus x dx. In the second part, I have 1 minus x dx. Now, let's take the integral. Integral of 1 is x. Integral of x is x squared over 2. Let's evaluate this antiderivative at 0 and negative 1. Plus, similarly, integral of 1 is x, minus integral of x is x squared over 2. Evaluate this at upper bound and lower bound one by one. Let's look at the first part. The first part is substituting 0 will result in 0 minus, let's substitute negative 1 for x. Negative 1 plus negative 1 squared over 2. I'm done with the first part. Plus second part, substitute 1 first. 1 minus 1 squared over 2 minus substitute 2, 0. It will give you 0. Right? Now let's solve it. Here I distribute negative. Negative makes positive 1. Negative positive makes negative 1 over 2. Plus 1 minus 1 over 2. 1 plus 1, 2, minus 1 over 2, minus 1 over 2 makes minus 1. 2 minus 1 makes 1. So integral from negative 1 to 1 of 1 minus absolute value x dx is 1. So this is the way of solving absolute value integrations. Let's take a look at another one by using the same idea. Let's find the boundary number or critical value first. So what makes absolute value 0 here? X minus 3 is 0, then x being 3. So I'm going to break this integral into two pieces. Integral from lower bound to the boundary number here of 3 minus. How this absolute value come out? When you pick a number less than 3, like 2, it will make inside negative. So you take the opposite of expression. Opposite of x minus 3 is negative x plus 3 dx plus the second part is the critical value to the upper bound 3 minus. When I insert a number bigger than 3, it's going to make inside positive. So I will take the same expression out. Okay, now let's simplify a bit. 1, 2, 3 of 3 minus minus x plus x minus 3 plus 3 will be 0. So I just have x plus 3 to 4, 3 minus x minus x, 3 minus minus plus 6 dx. Now let's take integral of each one by one. Integral of x squared over 2, evaluate this antiderivative at 3 and 1, plus integral of negative x squared over 2, plus 6x, evaluate this at 4 and 3. Now let's insert the upper bound first. 3 squared over 2 minus lower bound 1 over 2 plus, now insert upper bound first, negative 4 squared over 2 plus 6 times 4 minus, open bracket, I have two terms. Insert the lower bound, negative 3 squared over 2 plus 6 by 3. Now let's simplify. 3 squared is 9, 9 over 2, minus 1 over 2, minus 4 squared is 16, 16 over 2 is 8, 6 times 4 is 24, minus, here I have negative 3 squared, negative makes positive, 9 over 2, 6 times 3, 18, I have negative in front, negative 18. Let's simplify this. 9 over 2 makes 9. Negative 1 over 2. Negative 8, negative 18, negative 26. Plus 24, negative 2. So I have 7 minus 1 over 2, which is, when I equalize denominators, 13 over 2 is the answer to this integration. So these are the similar questions. I'm done with absolute value integration. Next lesson, I will be explaining the mean value theorem.